All right, so for Unit 3, the atom, the main things are protons, neutrons, and electrons. And there's a couple other vocabulary words I use to describe things about the atom. So if I look at the periodic table, that gives me a lot of information about whatever atom I'm looking at. If I look at carbon, for example, this 6 up top is the number of protons. It's actually called the atomic number. For a neutral atom of carbon, so there's no charge, protons has to equal electrons. So whenever I'm dealing with atoms, the atomic number also tells me the number of electrons. This number right here is called average atomic mass. This isn't specific to any one carbon. It means if I take all the carbons in the world and I average their mass, the average of all of them is 12.01 AMU, atomic mass units. So all the carbons in the world average out to 12.01. But I oftentimes want to look at a specific carbon. So let's say, for example, I wanted to look at carbon 13. Now this 13 right here is what we call the mass number. This tells me the number of protons plus the number of neutrons. So because it's carbon, I know carbon has 6 protons. And if protons and neutrons is 13, I can do 13 minus 6 and figure out that I have 7 neutrons in carbon 13. Instead, if I wanted to look at carbon 14, I have 2 ways of writing it. I could write out carbon 14 just like you saw with carbon 13, or I could write this, carbon, a 14 on top because I put my mass number on top, and a 6 on the bottom because I put my atomic number on the bottom, which sets me up for a really easy way to find the number of neutrons. I just subtract atomic number from the mass number, which gives me 8, and I know that carbon 14 has 8 neutrons instead of 7. Carbon 14 and carbon 13 are what we call isotopes. You can't say that carbon 14 is an isotope, because it's an isotope of what? That's like saying I'm friends. Friends with who? Right? You need at least 2 people to be friends, otherwise you're a little weird. We need at least 2 atoms to be isotopes. So we can say carbon 13 and 14 are isotopes. Same atom, same number of protons, same electrons. The only thing that changes is the number of neutrons, which changes my mass number. Average atomic mass takes into account all the isotopes I have. So what this tells me is that most of the carbon in the world is carbon 12, because it's really close to 12, and I might have a little bit of carbon 13 and maybe an even smaller amount of carbon 14. Most of the problems with the atom, you're literally trying to figure out what's the mass number, what's the atomic number, what's the number of protons, what's the number of neutrons. The only thing that might change in the atom is if they say you're going to make an ion. So say instead I looked at sulfur. If I look at my periodic table, sulfur is number 16. Say instead I wanted to know the number of protons, neutrons, and electrons in sulfide 33. Well, the first thing I notice is it's sulfide, which tells me I'm not just looking at sulfur, I'm looking at sulfur with a charge, so S2 minus. I know that because of the columns on the periodic table, it's 2 over. So if I look at this, to get a 2 minus charge, I know I need to give it 2 electrons. So first I'm going to do the easy one, number of protons. I know it's 16. Then I'm going to find number of neutrons. I'm going to take my mass number, 33, and I'm going to subtract the number of protons, 16, and I know I have 17 neutrons. The tricky one on this one is electrons. Normally, electrons would equal protons, so normally I'd have 16 electrons. But I know that because it has a 2- charge, I'm actually going to give it 18 electrons. If it had 16, it would be neutral. But because it's 2-, it has 18. The only other piece of information about the atom that's important is if I didn't pick an anion, if I instead picked a cation. Something like, say I gave you calcium ion, because they don't change their name, so I can't write I, 41. Well, if I look at calcium, it's number 20. So protons, 20. Neutrons, I do 41 minus 20, so it would be 21 neutrons. Now if I look at the number of electrons, okay, well calcium, if it was totally neutral, would have 20 electrons. But instead, it forms a 2+ charge, and I know this by looking at the columns on the periodic table. So to get a 2+ charge, I have to take away 2 electrons. So that means I take away 2 from 20, which would be 18. So calcium, the ion, has 18 electrons. Calcium atom would have 20.